Welcome to another deep dive. Today we're going to be getting pretty small, actually microscopic, to explore the fascinating world of phytoplankton.
Oh, very cool.
And they have a critical role in climate change.
Interesting.
Yeah. So we've got this really cool news article about a new NASA buoy project, and that's what we're going to be diving into today.
Most people don't even realize that phytoplankton exist.
Right.
Let alone how important they are.
It's mind-blowing how these tiny plants, and I mean T-I-N-Y, are responsible for producing more than half of the world's oxygen through photosynthesis.
Yeah.
That's more than all the rainforests and trees combined.
That's right. They're like a hidden forest in the ocean, working tirelessly to keep our planet habitable.
Okay, so tiny but mighty. I like it. They're the real MVPs of the oxygen game. But wait, there's more.
Oh, there's always more.
Not only do they pump out oxygen, but they also absorb massive amounts of carbon dioxide.
Really?
Almost as much as all land plants combined. Talk about a 1-2 punch in the fight against climate change.
Exactly. And that's where this new NASA project comes in.
Yeah.
It's called MarONet. And it's basically a high-tech buoy stationed off the coast of Australia.
So what's so special about this buoy? Does it, like, sing to the phytoplankton or something?
Not quite, though. That would be interesting.
Okay.
It actually measures the color of the ocean.
What?
Which might seem strange, but it's directly related to phytoplankton levels.
Okay. I'm intrigued. Explain how that works. I thought the ocean was just well blue.
Yes, the ocean generally appears blue because water absorbs the longer wavelengths of light, like red and orange, but the presence of phytoplankton adds shades of green to the mix.
Okay.
Because they contain chlorophyll, which absorbs blue light.
Oh.
So areas with lots of phytoplankton look more blue-green. It's like they're signaling us from below.
So MarONet is basically keeping an eye on how blue-green the ocean is. And that tells us how much phytoplankton is there.
Precisely.
Wow.
And this data plays a vital role in calibrating data from NASA's PACE satellite, which also monitors ocean color from space. It's like having a ground truth checkpoint to ensure the satellite's readings are accurate. Think of it like using a map to navigate.
Right.
You need landmarks to make sure you're on the right track.
Yeah.
MarONet provides those landmarks for the satellite.
Okay, that makes sense. So MarONet is like the ultimate fact checker, making sure we have the right intel on these phytoplankton powerhouses.
Yes.
But why is knowing all of this so important? What's the big picture here?
Remember how we talked about phytoplankton absorbing carbon dioxide?
Yeah.
That process is a key part of the global carbon cycle.
Okay.
Which is essentially how carbon moves between the atmosphere, the ocean, and land. Phytoplankton act like little carbon capture machines, drawing it down from the atmosphere.
Wow.
This helps regulate the Earth's climate, acting like a giant planetary thermostat. But what happens when that thermostat starts to malfunction?
That's where climate change comes in, right?
Exactly.
Oh, boy.
As our climate changes, it affects the ocean in various ways. Like warmer temperatures, for instance, can throw off phytoplankton growth and distribution.
Oh, no.
It's like they're trying to thrive in a hot tub instead of a swimming pool.
Right.
Not ideal conditions for these microscopic gardeners.
So understanding how phytoplankton populations are changing and how effectively they're absorbing CO2
right.
is crucial for predicting future climate scenarios and coming up with solutions.
Exactly.
It's like we need to know how much carbon they're capturing.
Yes.
And how that might change as the planet warms.
Precisely. And that's why projects like MarONet are so valuable. They're providing scientists with vital data to understand these complex interactions and hopefully guide us towards a more sustainable future. It's like having a window into the health of our planet, all thanks to these tiny but mighty phytoplankton.
So we've established that phytoplankton are these incredible oxygen factories and carbon capturing machines.
Yes.
But it sounds like climate change is throwing a wrench in the works.
That's right. Phytoplankton are facing some serious challenges in a warming world.
Okay, so let's unpack that a bit. What are some of the biggest threats they're facing?
Well, one of the major concerns is ocean warming as water temperatures rise.
Right.
It can disrupt phytoplankton growth and distribution.
Yeah, that makes sense. It's like trying to grow tomatoes in the desert.
Yeah.
They need the right conditions to thrive.
Exactly. Different species of phytoplankton have different temperature tolerances.
Okay.
Some might actually do better in warmer waters, while others could really struggle.
So it's not just about the overall amount of phytoplankton, but also the diversity of species.
Right.
We need a vibrant mix to keep the ecosystem healthy and resilient.
Absolutely. Biodiversity is key.
Yeah.
A diverse community of phytoplankton is better equipped to adapt to change and support the entire marine food web. It's like having a diverse team.
Right.
You've got all your bases covered.
Right. So warming waters are one issue, but I know there's also the problem of ocean acidification, right?
Yes.
That's basically the ocean becoming more acidic because it's absorbing all that excess CO2 from the atmosphere.
Precisely. And this increased acidity can really mess with phytoplankton, particularly those that build shells out of calcium carbonate.
Oh, so it's like trying to build a house with dissolving bricks, not a recipe for success.
Exactly. It's like their building materials are being weakened.
Yeah.
And if phytoplankton populations decline, it creates a ripple effect throughout the entire ecosystem.
Either they're the base to the food chain, right?
Exactly. Everything from tiny zooplankton to large whales ultimately depends on phytoplankton for food. They're the primary producers, the foundation upon which the whole marine food web is built.
So it's like a domino effect. If phytoplankton are in trouble, the whole ocean ecosystem feels the impact.
That's right. And this is why understanding the complex interplay between phytoplankton and their environment is so crucial. It helps us anticipate potential problems and develop strategies to protect these vital organisms.
So we're not just studying phytoplankton in isolation, but looking at how they fit into the bigger picture of the ocean and how they're being impacted by climate change. It's a holistic approach.
Exactly. And that's where projects like MarONet come in. They're giving us this incredibly valuable data on phytoplankton dynamics, helping us track changes in their populations and distribution. We can start to piece together how they're responding to these various environmental stressors like warming waters and acidification.
So it's like having a finger on the pulse of the ocean, constantly monitoring its health and seeing how these tiny but mighty phytoplankton are holding up.
Precisely, and this continuous monitoring is essential for detecting early warning signs of trouble and guiding informed decision-making. We need to be proactive, not reactive, if we want to protect the ocean.
All right, so we've got this amazing technology like MarONet helping us understand the challenges facing phytoplankton, but is there anything we can actually do to help them? It feels a bit overwhelming, like these global problems are just too big to tackle.
It's true that climate change is a complex issue, but that doesn't mean we're powerless. Individual actions might feel small, but they can collectively make a big difference.
Okay, so what can we do on a personal level to support these phytoplankton heroes?
Well, reducing our carbon footprint is a great place to start. It's all about making sustainable choices in our daily lives.
Okay.
Things like driving less conserving energy at home and being mindful of our consumption habits.
Right. Those small changes can add up when we all do our part.
Yeah.
It's about recognizing that our actions on land can have a direct impact on the health of the ocean.
Exactly. And supporting organizations and initiatives that are working to protect our oceans is another important step. There are some fantastic groups out there doing research, advocating for policy changes, and raising awareness about the importance of ocean conservation.
So we can support those efforts with our time, our donations, or by simply spreading the word.
Absolutely. It all contributes to a healthier planet for phytoplankton and for all of us. And I think it's important to remember that learning about these issues is a powerful act in itself. The more we understand about the ocean and the challenges it faces, the better equipped we are to be advocates for change.
That's a great point. Knowledge is power.
It really is. So as we continue to explore the world of phytoplankton, keep in mind that even though they're microscopic, their story is a big one, and it's one that's deeply intertwined with our own.
Well, this has been an eye-opening journey so far. We've gone from marveling at their oxygen-producing superpowers to understanding the threats they face in a changing world. But I'm curious, are there any glimmers of hope on the horizon? Can we actually harness the power of phytoplankton to not just monitor climate change, but maybe even help us mitigate it?
That's the million-dollar question, and it leads us to some really exciting areas of research.
Okay, I'm all ears. Let's dive into those possibilities in the final part of our deep dive.
All right, we're back and ready to explore some potential solutions.
Okay.
I'm really curious about this idea of harnessing phytoplankton to combat climate change. It sounds almost like science fiction.
It does sound a bit futuristic, doesn't it?
Yeah.
But it's an area of research that's gaining a lot of attention, and one of the most talked about ideas is iron fertilization. All right, we touched on that earlier. It's basically giving phytoplankton a boost of iron to encourage them to grow more, right? Kind of like a superfood smoothie for these tiny plants.
Exactly. Iron is a key nutrient for phytoplankton growth.
Uh-huh.
And in certain parts of the ocean, it's actually in short supply. So the thinking is if we strategically add more iron, we could spark these massive phytoplankton blooms, leading to a greater uptake of CO2 from the atmosphere.
So it's like giving them the fuel they need to become even more powerful carbon-capturing machines.
Yes.
It sounds promising, But I imagine there are some concerns too. What are the potential downsides of messing with the ocean's natural balance like that?
You're right to be cautious. It's not a simple solution, and there are definitely risks involved.
Yeah.
One concern is that artificially stimulating phytoplankton growth could lead to harmful algal blooms, the kind that deplete oxygen in the water and harm marine life.
Oh, no, that makes sense.
Yeah.
We don't want to create a whole new set of problems while trying to solve another.
Exactly. And another question is how long the absorbed carbon would actually stay locked away in the deep ocean.
Right.
We want to make sure it's a long-term solution, not just a temporary fix.
So it's a complex issue with a lot of unknowns. It sounds like we need a lot more research before we start dumping iron into the ocean willy-nilly.
Absolutely. It's not something to be taken lightly, and that's where projects like MarONet are so important. They're providing scientists with the data they need to model and predict the potential consequences of these kinds of interventions. It's like running simulations before taking any real-world action.
It's like a safety net, helping us make informed decisions and hopefully avoid any unintended disasters.
Exactly. And it's important to remember that iron fertilization is just one potential avenue for harnessing the power of phytoplankton.
Okay.
There are other exciting areas of research being explored as well.
Oh, really? Like what?
Well, some scientists are looking into using phytoplankton to produce biofuels, for example. Imagine powering our cars and homes with energy derived from these microscopic powerhouses.
Wow, that would be incredible. Turning tiny algae into fuel, it sounds almost too good to be true.
It's definitely a field with a lot of potential.
Yeah.
And there are even researchers exploring the possibility of using phytoplankton as a sustainable food source.
Why?
They're packed with nutrients and could offer a solution to global food security challenges.
So these little guys could be the key to a cleaner planet, sustainable energy, and even feeding the world. It's amazing to think about the possibilities.
It really is, and that's why it's so crucial to continue investing in research and understanding the full potential of phytoplankton.
Right.
They might be microscopic, but their impact could be monumental.
Well, I think we've all gained a whole new appreciation for these unsung heroes of the ocean today. They're not just pretty green swirls in the water. They're vital to the health of our planet and maybe even our future.
I couldn't agree more.
So to our listeners, we leave you with this thought. Sometimes the smallest things can have the biggest impact the next time you look out at the ocean. Remember the microscopic world teeming beneath the surface, working tirelessly to keep our planet alive.
And never underestimate the power of curiosity and exploration. Who knows what other secrets the ocean holds just waiting to be discovered.
Thanks for joining us on this deep dive into the world of phytoplankton. Until next time, keep exploring and stay curious.